Welcome to CEC lectures. Myself Dr. Preeti Jagwani. I am from Department of Computer Science, Arabic College, University of Delhi. So in our previous lecture we have started with a very important topic, which is an important pillar of object oriented programming paradigm, and that is nothing but inheritance. And we have seen that how this concept of inheritance is going to be implemented in our programming language Java. So that is basically we will be having a superclass and then a subclass which is going to extend that superclass. So that was the first concept which we have seen, and then moving further we have also seen that if there is a private member which is being declared inside the superclass, so that member being private cannot be inherited by subclasses. So that means private members are actually private to the class in which they belong. They cannot be inherited by subclass, or within the subclasses they cannot be exist, I can say. And now here in this lecture, what are we going to do? We are going to going to combine the concept of inheritance along with the constructor. So constructor, you are aware that what actually a constructor is, and also you are aware that how to pass objects to a constructor. So with that platform in mind, let us try to explore this concept of constructors along with the inheritance using a program. So here I am going to take a class box, and this is kind of an example which we have seen many a times in our previous program, many in our previous lectures also, and we have built many programs around this this class box, which is having three variables which are double variables of width, height and named as width, height and depth. And here we have used one constructor, and one object is being passed to the constructor. So the constructor is named obviously as box, and within the parameter we are going to write box OB, and width is equals to OB dot width, height is equals to OB dot height, and depth is equals to OB dot depth. So whomsoever is going to call this constructor, the width, height and depth of that particular object will be initialized with the width, height and depth of the object which is being passed as the parameter, and which is going to we can say which is going to be tied up with this object OB. And I am sure you are aware with this concept in a detail at a detail level, because this we have already covered in our previous lecture. And here is one more constructor which is doing nothing, but it is assigning the value of W, H and D, and these are the three parameters which are being passed to this particular we can say constructor, and the value of width, height and depth is going to be initialized by the value of W, H and D. So here is we can say another simple concept. Now again a constructor in which the no dimensions are specified, and we are using width is equals to -1, height is equals to -1, depth is equals to -1, and in a way this is going to be used to indicate an uninitialized box, we can say. So till this point in this program we have seen three versions of this constructor. So one more to add here, which is taking one parameter length, and that parameter length is going to be assigned to width, height and depth. So that means width, height and depth are now equal, and this box is of a dimension of a cube. So that means we are trying to create a cube using this box. And then we have a double volume which is returning width, height and depth. So in this class we have used the constructor which is passing which is taking objects. Then we have seen the constructor which is taking three values W, H and D. Then we have seen the constructor which is not taking anything, no dimensions. That means dimensions are not specified here. And we have also seen one constructor which is taking one particular we can say variable, and that value of that variable is being assigned to all the 3 variables, and then there is a volume function which is returning width, height and depth. Now this class box is actually going to we can say act, or this is actually going to serve us as the superclass. So if this is the superclass, we need subclass. So that means we are going to write one more subclass, and here is the subclass which says class box weight extends box. So box weight here is the name of the subclass, while box is the superclass, and it is kind of we can say adding one more instance variable which is weight. Obviously that this is also of type double. And what is going to be the constructor of box weight? A parameterized constructor will take 4 values, which is double W, then H, then D and then M. The value of M will be assigned to weight, W is to width, H is to height and D is to depth, and this whole program you can see on the screen. So we have defined one superclass with 4 types of overloaded constructor into that, and then we have extended that box, taken it as a superclass, and now we have this subclass which is adding one more member which is weight. So now here we are going to create two in another class which is going to define our main function. So we have here class demo box weight, in which we have defined main, public static void main, as you all are aware, and we have created 2 we can say objects of the class box weight. One object or one kind of reference variable to the object is named as mybox1, another one is named as mybox2, and here we are calling new box weight, and some parameters are being passed, 10, 20, 15 and 34.3. Well, 34.3 is going to be the weight, and 10, 20, 15 will be the width, height and depth. Similarly, for the second kind of object which is mybox2, this object is also belonging to the class box weight. We have 2, 3, 4 and the weight is 0.076, and we are also calling the function volume, and the value, whatever value is being returned by volume, is being stored in the variable VOL. So VOL is equals to mybox1 dot volume. We have printed it, and then apart from printing the volume of the mybox1, we have also printed the weight of this mybox1 by using the variable mybox1 dot weight. And also this this functionality is actually repeated for our next object, which is mybox2. So VOL is equals to mybox2 dot volume, and VOL is being printed, and so is your mybox2 dot weight. So for both the objects we have printed 2 things. One is the volume, which is being returned by multiplying the height, width and depth, and another one is the weight. So what actually we did in this program was, we have created one superclass, we have extended that class, and within that class we have added one more member, and also define the constructor which is belonging to the subclass. But what we can kind of exploit in our upcoming sequences is, a major advantage of inheritance is that once created a superclass that defines the attributes which are common to a set of objects, and that's what your superclass actually means, that can be used to create any number of more specific subclasses, and each subclass can precisely tailor to its own classification. So for example, in our just the program which we have seen, we have extended the class box to a subclass which is box weight, and in the kind of we are going to extend that class box, or we are going to use that class box with one another class which is named as color box, and instead of adding weight here, which we did in our previous subclass, we are going to add the color, which is kind of an integer, and here we have also defined the color box, which is the constructor of our subclass, I can say. So color box, which is having a W, H, D. So W, H and D are the three variables which are inherited to color box by box, and C, which is the color or the color variable, is going to be, we can say, its own variable. So the value of W, H and D are being assigned to width, height and depth, and the value of C is being assigned to color. So here, but in this example, what we did earlier, we have defined a full-fledged we can say superclass. We have taken that superclass and created more classes by inheriting those properties of superclass which are there, and we have also kind of reused that superclass with two subclasses. One subclass is adding the weight as its own variable, another subclass which is adding color as its own variable. So this is what the utility of superclasses and subclasses with reference to the constructor that we have seen. Now what we are going to explore next is a superclass variable can refer to a subclass object. I repeat it here. A superclass variable can refer to a subclass object. So a reference variable of a superclass can be assigned reference to any subclass derived from that superclass. What exactly this particular we can say this particular situation or this particular statement means, that is, a superclass variable can reference to a subclass. Let us see this with the help of a program. So here, please remember, or please recall that weight box, which was I can say a subclass, and the superclass for that was the box. So now we are assigning the weight box to we are assigning the box with reference to the box reference. So here I am considering this plain box as the reference to the box class, and weight box 2 is actually a reference to the I can say box weight, which is nothing but a subclass. And now we are calling volume, that is plain box dot volume, whatever is being assigned by whatever is being calculated by this function volume will be assigned to VOL, and this is perfectly okay, because volume, that function volume, is also defined in volume is actually defined in box, and with plain box we can also, plain box is actually a reference to the class box. So whatever is a reference to the class box, we can use the functions which are defined inside this class box within with its own object. So here, because of this thing, we are able to use the function volume with the plain box. But let's say, for example, if I am going to kind of, or if I want to access the variable weight with the plain box. Now this is not allowed. Why this is not allowed? Because weight is actually a variable which is being defined inside the subclass, and plain box is actually a reference which is pointing towards the superclass. So that's why this statement in which we are going to which we are trying to access plain box dot weight will be invalid, because of the simple reason that plain box does not define a weight member. Weight member is actually defined by the subclasses, while plain box is a reference to the we can say superclass. So here we can see this program as a whole, that within the main function we are going to have one weight box object, which is the object of class, we can say of the subclass, and for the superclass we have plain box, which is the reference variable. Then we have a volume variable in which the volume of the weight box is being assigned. That is perfectly fine. Weight box dot weight is okay, because weight box is the object of the subclass, and assigning the weight variable, which is the instance variable of the subclass, is fine. But if we want to do this with the our plain box, that means plain box dot weight, that we will not be able to access, because plain box does not define a weight member. It is only defining the three members, which are width, height, and depth. It is not defining any weight members. So that we need to be careful with. So that means while assigning or while accessing the variables or while accessing the members using using various references which are kind of pointing towards the subclasses or the superclasses, we need to be a little careful with, because here box weight is actually a subclass of box. It is permissible to assign plain box a reference to the weight box object. That is also we can say is allowed. So in this example, so basically what are we trying to say here is, when we say that it is permissible to assign plain box a reference to the weight box object, it is the type of the reference variable, not the type of the object that it is referring to, which is going to determine what members can be accessed. That is, we can say, when a reference to a subclass object is assigned to a superclass reference variables, only those parts of the objects which are defined by the superclass can be accessed, but not all the variables. So when a reference to a subclass object is assigned to a superclass reference variable, which we are going to demonstrate with the help of a program, only those parts of the objects which are defined by the superclass can be accessed, and that's why our plain box cannot access the weight even when it refers to the box weight object. So if even if your box weight is going to, your plain box is going to refer to the box weight object, it is not going to it will not be allowed to access weight, because that is something which is kind of not allowed here. It is not permitted, because the superclass has no knowledge of what a subclass is going to add to it. So it is not possible for a box reference or a superclass reference to access the weight field, which is the field which is being added by the subclasses, because the superclass, which is the box, is not going to define one. It has not defined that particular thing. And in the previous example, the constructor for the box weight explicitly initializes the width, height and depth of the box. Not only this duplicates the code found in its superclass, which is inefficient, but it implies that a subclass must be granted access to these members. So where is the problem? The problem is we are placing two different constructor, one in the subclass, another one in the superclass, and the subclass is explicitly assigning the width, height and depth, which are actually belonging to the box. So here is a duplication of code, because that assignment through a constructor is also done inside the class box, that means the superclass, and we are actually repeating that code inside the superclass. So not only this is duplication of code in the whatever is available in the superclass is being duplicated in the subclass again. This is going to introduce an kind of inefficiency to the program. And second, I can say the disadvantage or the dilemma here, it is implying that all those members of the superclass which are width, height and depth are actually granted access, or a subclass must be granted access to these members. So there are these two dilemmas. One is the duplication of code and another one is related to access. Now there can be certain situations when we want to create a superclass that keeps the details of implementation to itself, or we can say that is that keeps its data members private. So then in our previous program we have I can say we have specified or we have seen that private members cannot be inherited by subclasses or cannot be used by subclasses. So in this case there would be no way for a subclass to directly access or initializes these variables on its own. So now here is a problem. We are saying that in a way we are providing the access to the members of the superclass to the of the members of the superclass, and we are providing that access to the subclass. And if we are going to make them private, there will be no way for a subclass to directly access or initialize those variables, while subclass is actually using that variables of width, height and depth. So Java actually provides a solution to this problem. So the solution goes with the help of the keyword super, super. So whenever a subclass needs to refer to its immediate superclass, it can do so by using the keyword super. I'll just repeat this line once again. Whenever a subclass, for example box weight, needs to refer to its immediate superclass which is box, it can do so by the use of the keyword super. So now here we have one more keyword into a kitty, and that keyword is nothing but a super, but the term super, super, and this is actually kind of this term or this keyword is having its own importance in Java when we talk about the term inheritance. So super here is going to have two general forms. One which we have just described, which is calling the superclass constructor or calling the constructor of the superclass, and the another use is to access a member of the superclass that has been hidden by a member of the subclass. So that means two general forms or two situations here in which we are going to use super keyword. One is to use superclass constructor and another one is to access a member of the superclass which is being hidden by a member of a subclass, and we will be exploring these two situations one by one. So first of all, let us take the first scenario in which the super calls the constructor of the superclass. That means the keyword super is going to call the constructor of the superclass. So here it is, it goes like this. So a subclass can call a constructor which is defined by a superclass by the use of the following form of super. So that means super, that keyword is going to be written, and within that keyword we are going to write an argument list. Which argument list I am talking about? The argument list is which specifies any arguments that are needed by the constructor which is needed by the constructor in the superclass dot super, and this super statement, that means super and the argument list, must always be the first statement executed inside a subclass constructor. So here it goes like this, that within the we can say the constructor of the subclass, we can use we can call the constructor of the superclass by calling it with this statement which we have just seen, but the condition is that statement should be the first one to be executed inside a subclass constructor, and it goes like this here. So we have one class which is box, obviously that's the superclass we have seen in our previous examples, and we have box weight, which is kind of earlier it was initializing the width, height and depth and also the weight. Weight is its own member, while the width, height and depth are the inherited members. Now here we are not going to initialize the weight, height and depth in this constructor. Instead, we will be calling whatever has been initialized by the superclass constructor, and here we are going to do it like this. So within this constructor box weight, we have double W, then H, D and then M. So instead of writing width is equals to W, height is equals to H and depth is equals to D, which is kind of a duplication of code, because this we have already done in our superclass constructor. We are just calling the superclass constructor by using the keyword super. So keyword says super and then the argument list. So the argument list goes like W, H and D, and whatever the next argument which is remaining is M. The value of that argument M is assigned to the new member or the member which is being added by the class box weight itself. So box weight is calling the constructor of its superclass which is box using the keyword super. This keyword super is being used with the arguments W, H and D, and this will cause the box constructor to be called, and the variable inside the box constructor which are width, height and depth are being assigned by W, H and D passed here through the keyword super, and box weight here is no longer initializes these values itself. It only needs to initialize the unique value which is which is a variable of its own, and that variable is nothing but weight. So what is the advantage here? Advantage is we have removed the redundancy of the code, and this will leave box free to make these values private if desired. So even if these values are kind of private inside the box, that is perfectly fine, but they can be used with the help of super. But another point or another usage of super is still yet to be covered. That I will be covering in my next lecture. So here in this lecture we have started that how this constructor are going to be used with reference to the inheritance thing, and how these reference variables are going to be used with reference to the superclasses and subclasses. Here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed one. I will see you in the next lecture. Till then, take care. Goodbye.